Happy New Year, everybody. My name's Josh, and this is Project Blue Smoke Monster. Tonight we're going to be working on the laser cutter a little bit. So for those of you that don't have the backstory, well, before I get into it, let me talk about what's been going on. I haven't done a ton of streams in the last few months. I've been out chasing some life goals. I successfully completed my private pilot's license. That's been something that's been on my plate for the last 18 years. I decided it was time to focus and get it done. So that's what we've been doing. That is now behind me. I am now a certificated pilot and can move back into some of the other fun stuff in my life. This laser is referred to as a red and black. It is a 700 by 500 millimeter cutting surface. And it's pretty big in terms of a home laser. I don't know the dimensions on the Glowforge, but it's significantly bigger of a device than that. It's a water-cooled CO2 laser. I have a chiller, a proper chiller attached to it. And I was trying to cut out some Christmas ornaments out of acrylic here a few weeks ago. And that's the first time I'd had the laser even connected since I moved into this house about 2 years ago. It's taken some time to get everything here in the lab running. And we're still not 100% far from it, but baby steps, right? And the lab's my creative space, which means it looks like an atomic bomb went off. I accidentally, well, I don't know if it was my fault or if shit just broke. The high voltage power supply failed, and basically the flyback transformer cracked open, so the laser no longer lasered. I reached out to Light Object, love you guys, and ordered one of their 60, 70 watt power supplies. I don't know exactly what model number it is, I'd have to look, but this is a 60 watt machine. I considered for a minute getting a bigger power supply and then getting a bigger tube and just doing an upgrade, but I don't feel like doing that right now. I'm going to wait until the tube dies completely before I do that. So we are going to attempt to install the new power supply in the laser. Hopefully the laser itself is good and we can dial the machine in and get it back to doing its job. So I expect that the power supply that I purchased is a much higher quality unit than what came with it. It certainly looks nice. First problem, it doesn't fit. It's physically larger than what I'm replacing. A few inches physically larger, I think. So it means we have to rework the electronics bay. And that's not as simple as just drilling a couple of holes and putting some screws in. It literally won't fit. So I need to condense some of the free space and make a little more room in the electronics bay so that I can mount it. Well, here's what that actually means. It means that I have to disconnect the entire machine's wiring system, and the electronics bay, all of the electronics, the power supplies and the stepper drivers, and the Ruida controller, they all sit on a floating metal panel that can be removed. I need to remove the panel, unmount the stuff that's attached to it today, move it around in a suitable layout, reattach it, and then rewire it. And with a little luck, I can just move wires around. If I'm not so lucky, it's going to be literally rewiring the machine. Now, not a super scary job, but one that you want to take your time and do correctly. And I'll be well suited for the future should I need to replace the power supply again, because I would definitely be going Light Object again. So, yeah. I've opened the machine up, and I'm going to get in front of it here in a minute. I've got the only camera angle I can make work basically right now. And we're going to start documenting and disconnecting the electronics from the electronics bay and preparing to do the stuff you do when you're going to rewire a laser cutter. I love this machine. and don't want anything else. So, I apologize, my head will be a bit in the way. There's nothing I can do about it. I'm going to pull up Twitch on my phone so that I can hopefully, at least a little bit, monitor chat. Oh yeah, we can see it. Do I see chat from here? I don't know if I can. I'm going to find out. Watch, I guess? Live. Yes, I know I'm live. Show me my chat. Stream manager. 8:58 p.m. Ashley 199725 followed you. Thanks, Ashley. Appreciate that. Content. Oh, I see me live. I thought I could do chat here. I'm looking for it. Whispers. That's not it. I thought I could. Huh. I'm going to look around a little bit. Stream manager. Ooh, there it is. Stream manager. Chat. All right. Testing. 1, 2, 3. All right, there we go. I think we are now interacting with chat. So again, I apologize when my head's going to get in the way. It is what it is. We're going to remove this panel, labeling some things as we go, and pull the whole thing out and then rework it where we have a little better visibility. So, with that being the case, hey Eric, you love the hair. Yep, it's my Jufro. Alright. It's on the way to becoming much longer, but these things take time. Alright, so we're going to label things as they come out. So this is CN2. And actually, hang on, let me change how this thing's doing it, because I want to make it do like flags. Cable flag, there we go. Yeah, that's good. Okay. And print. Let's see how that looks. I mean, that's kind of the same thing. I mean, I get what you're trying to do there, cable. Do I like that? Not really. It's a lot more tape than I need. Let's see what else I can do. Cable wrap. That might look better. Yeah, I think I like that better. So, we're going to just start labeling things as they are in here. Actually, if I do it like a flag, but there we go. That's going to be nice. There's no perfect way to do this in the rush that I'm in, but I just want to know where things came from. Because it's going to be important. CN4 for the next one. Even as I rewire the entire machine, I really need to know where things go. Each of the wires, I mean, potentially could have to be redone. And I'll tell you what, I don't know exactly who makes the red and black laser, but they did a fairly good job on the wiring. They've used, you guys can't see it from the camera angle, but they've used hot melt glue. So they've used ferrules on stranded cable, inserted the cable, tightened it down, and then used hot glue to keep things from just wiggling loose, which is awesome. This is going to be our Z-axis. So it's not a bad cabling job to start, but it does, does have a lot going on, so with me needing to move things around, if I have to rework it, I will. CN5. And basically, I'm unplugging everything in here and then pulling the bolts that hold the panel. There's also, you can see them a little bit in here, these blue channels, like Panduit type of channels, that I also really like. So I'll try to preserve the integrity of those as much as possible. Let's see here. Cable cutter, nice. Let's cut a zip tie. Got it. Again, this is going to be the X and Y axis. I'm a big fan of the red and black laser. It does take up some space, but it does a really good job. This one does not have a motorized Z-axis. So, Eric, I don't know the make and model. It's referred to as a red and black. It's a 300 by 700 millimeter laser. And you get them on eBay or AliExpress, and they drop ship them from China. So it's a whole thing. You know, you got to get a lift gate for delivery. Lift gate service, you know. The thing weighs about, probably 600 to 800 pounds. But mine's in the basement. So yes, it is in the house. I had to take it apart to get it downstairs. All right. The Ruida controller is successfully disconnected. But yeah, I've had the laser about 6 years. And I'm still on my first tube. Now, I haven't worked it to death. But I have worked it. Okay. I don't know which axes these are. Are they marked X and Y? No, but I can follow some things. Why? Why? Because I like you. Alright, that's Y. This is X. Alright, we're going to label this X. So we know that the X signal good, that can come undone. And then the X motor. Which is that. And the XDC, which is that. We'll get that in a minute. This is the X motor. Yeah, I'd be crazy to not be labeling this. It's not like it's super hard, but the amount of time you could potentially waste. So XDC. And then YDC. Okay, XDC. That's a little 2-pin right here. But when the power supply in this thing died, it went with a bang. It completely suicided itself. It was not a little whimper. It was a kaboom. And of course the laser immediately stopped lasering. Alright. Cable, actually we'll leave that down here. There's a cable comes out. That's labeled, that can be disconnected. And we'll bring it away. That's the X motor. And don't think that you could do this from memory. You couldn't. Again, it's not a complicated wiring job. It's just a bunch of wires. I mean, like right here, there's two cables coming together that are shared and crossed. Go into sensors and inductors. Not inductors. Inductive sensors. Right, so that's X. Oh, and I want to label that as X. X axis. And then Y axis. Z. Z works on a laser cutter because a laser has a focal length. You focus the beam. So you want to have the focus point of the beam, most of the time, assuming you're cutting reasonably thin material, in the center of your material. And mine, you adjust the Z by spinning a knob. I have begun the process of putting up a powered Z. I actually have a motor and a gear and the controller, but that's just a rabbit hole I haven't gone down yet. There's some mechanical fabrication that I need to get into to make that happen, and we're not there yet. All right, here's the YDC. Good. And then the Y motor. They spaced things apart pretty well in this machine. Really well, actually, for the parts they used. But since I'm changing the power supply to a larger unit, it just won't fit. This is actually the power supply we'll be installing. This is from Light Object. Really a nice machine. There's a test button for firing. Jupiter Co. 60 watt high voltage switch model laser power ordinary. LO-60W. 25,000 volts at 24 milliamps max. About $150 power supply. Not bad. Not bad at all. Alright, that's Y. Let's see. Cable flag. Okay. Was it Y axis? Yeah, just Y, okay. In what circumstances would you need to modulate Z axis? Well, if I want to, that's the flag, not the wrap. If I want to cut something an inch thick versus an eighth of an inch thick, this thing can cut something, 12 inches deep probably. So to move the surface away from the laser, cable wrap, enter. Again, putting that beam in the center of the cutting material. Now, I'm not saying I'd cut something 12 inches thick, but I might engrave on something that's 12 inches tall, and it needs to fit in the chamber, in the work area. Okay, that one's good. That can come out now. I've never moved it more than a few inches, but I have moved it. I mean, I move it for every cut because every material is different. And the focal point of the laser, it's not a straight line for inches at a time. You know, it matters that it's correct. Okay, X motor. Get that out of here. Oh, good, that's on one of those. So this is now able to be disconnected. I'm not going to unscrew that yet. I'll do that stuff when I get to the bench. So X and Y are disconnected. Certain cables have been able to be removed. Good. So now we're getting down into this power supply here. And I have pictures. I'm going to take a few more pictures. The Z is not fixed. Yes, you do. Once you've set it, no. Once you've set it, you do not have to move it. There are some lasers that have more advanced designs, heads, where it moves up and down if you were cutting on something contoured to follow where the Z distance is, but that's more advanced than what this does. All right, I'm going to take another photo. This power supply is a lot simpler, but I do want good representations of pictures. Okay, and now that I have a picture, I can look and see how these things are labeled. So AC, that's the AC input. Those two. And then the next two, or the next one's ground. And that one would be easy, just on color code of the wire. This is definitely a tool that I have not gotten my money's worth out of. And I don't mean that disrespectfully. I just have not used it enough. I need to use it a lot more. And would like to. Okay. So then I've got 24 volts. 24 volts, okay. Two of those then. We'll measure those. And this is just a supplement to the photos. Or the photos are a supplement to this. I guess it depends how you look at it. But we want all these to get back in the same place they were. Unless I make improvements on the wiring, which I might do, but you know, let's not scope creep this any more than we have to, shall we? It certainly works just fine. This is not my first laser either. My first laser I built from, let's see, 24 and then ground. I built it from a design called the Build Log 2.0. It was a desktop laser cutter. And it was cool. But I wanted something polished. And that's where this came in. This is a just use it tool. That was a constantly tinker with it thing. And once you get one of these red and black set up, it pretty much is just a just use it tool. Well, that needs to be ground. Okay, ground 1. We know that it's next to it. And then ground 2, and then 5 volts. I'd be curious to measure ground and chassis on this power supply, see if they go to the same place. I bet they do, but I don't know. When is ground not ground, you know? And then 5 volts. Yeah, I can definitely tell. There's probably going to be some rewiring. Now, luckily, we're going to be bringing things tighter together for the most part, not spreading them out. So hopefully that minimizes the amount of cutting and bodging together I have to do of wires. High voltage power supplies are prone to failure. You are absolutely right. They are. That's why I'm doing this. Wouldn't LED be preferable? If you want to engrave materials or cut materials that you can cut with a 2-watt laser, then yeah, I would prefer an LED. This is a 60-watt tube. I can operate on thicker materials than what a smaller unit can do, and that was appropriate for my mission statement. So it all depends on what you're trying to do. There is a right tool for the job, and for what I want to do, this was the right tool. Now we have to find a screwdriver and not fall over because I can't feel my legs. All right, actually, you know what, I just found something that might make this a lot easier. I can't feel my legs because they're asleep, by the way. All right. Ugh. Okay, there's an extension. There's a power drill. There's a bit. I'm going to try to disconnect this power supply. And first, I'm going to reach around and make sure power is disconnected, which I already did. I knew it. I did it. I checked it, but I just checked it again. Okay. Loose end. Here goes. That was maybe a little too much because I actually pulled the screw all the way out. So we'll... Although, you know what? It doesn't matter. That's fine. We'll let them fall and we'll redo them. But you are entirely correct when you state that high voltage power supplies are prone to failure. Yep, they sure are. Okay. That appears to be all disconnected. Hopefully I haven't lost any screws. But that's all loose now, so that's good. So I'm going to pull the wiring out of the channel because this whole tray is coming out of here. So everything needs to be out of those channels. And this will take a little redoing when it's time. Okay, and what is that? That is Ruida power. Welcome back, Eric. I apologize for the ads. They're necessary to help cover some of my expenses running this endeavor. If anyone would like to help me run the endeavor, your subscription would go a long way. You can subscribe free with Amazon Prime. So I'm told. Alright, cool. That's the connector. Alright, I think we've got everything on here disconnected. So we've got 4 bolts in the edges of this that are going to get removed in order to pull this thing out of here. And then we can make our way to the workbench. Yeah, I'm going to need, I don't know what size bolt those are. And I don't have a nut driver set down here. Ugh. Oh, my legs. Oh, another modification we're going to do while we're at it is we're going to add a milliamp meter so that I know how much current I'm drawing on the laser tube, which will help me run it at lower power levels and extend its life. Do I have something that will work for removing that? Those bolts are all too big. I never thought I'd say this, but I need a socket set in the lab. Not a tool I thought I'd need here. Well, let me see if I've got some needle nose pliers or anything that'll do the trick, because I don't really want to go all the way to the garage. Okay, here's some pliers. We'll be able to make do with these two. I'm happy I haven't knocked the camera off yet. Ugh. Let's see if we can loosen these things. Shouldn't take much. Nope, that didn't come off. Try harder. There we go. Ugh. There we go. Got it. Well, now that I know, or now that I have one of the bolts loose, I want to go find out what size socket will fit that so that I can properly remove the others. I'll be right back. This is a good time to pour yourself another glass of bourbon, if you're so inclined. Okay. Let's find the socket. I should have freaking guessed it. 10 millimeter. The world runs on 10 millimeter. It truly does. Okay, well, now that I know that, let's go socket driver and 10 millimeter. Does that work? No. That's not the right part. Is that the right part? There is an adapter for that, right? Let's see. Yeah, it's right there. No, that's not it. Don't tell me there's not a socket adapter in this toolkit. Well, that would have been a handy dandy tool for them to include. Oh, wait, hang on. Don't let me speak too soon. 910. There is a driver. That'll work. Okay, got the driver. Perfect. All right, excellent. We have a nut driver that will do the trick. So when I step away, I don't know what the range on this mic is. Do you guys get a bunch of hash and trash, or do I just go silent, or do you keep hearing me? Stepping down to Costco wine now. Hey man, there's nothing wrong with that. I just started a new diet. My goal is to lose weight this year. I need to drop about 80 pounds. I don't know that all of that's going to happen this year, but I'm going to start making some better choices and cutting back some of my alcohol consumption. We're not going to go too crazy, but I have to dial it back a little. There's just so many empty calories there. I'm doing the keto thing, and that means that Coca-Cola and me are going to have a little strain on our relationship. However, me and bacon are going to be tighter than ever. So it's all good. Okay, that is totally unbolted. So, if things work right, this should pull right out. And with that, we ought to be able to free it up. Ta-da! The electric panel. The brains of the operation. Now with that out, I can look at relocating. Probably to the desk, because the lab bench, well, we won't talk about what it would take to get that in order. At the moment, that's a whole nother Oprah. So let me move a few things around on the desk to make some room. And we'll see about getting eyes on this. This is a pretty cool way to do it. You know, I'm super happy that they gave me the room to be able to do this. Okay, time to move the camera. Bear with me. I'm going to come up with a nice way to mount this here. I want to keep it somewhat high in the air. That may not be in the cards. We'll play with that again in a minute. Hang on. Let me get over here so I can get eyes on what you're seeing. That's actually not terrible. I think that's what we have to work with, so we'll make do. Yeah. We'll make do. So the problem here is this little section is not big enough to hold the new power supply. It's taller, and obviously the hole patterns don't line up. I never expected that that would happen. But we need to make room here. Well, to make room here, I'll probably need to pull part of this Panduit out. I'll need to move the x-axis and the y-axis and these Panduits over closer to the Ruida controller, which is here. This is the DSP that does all of the cool shit with the laser. And then move this power supply over to make a bigger hole here. That's what I think is probably going to happen. But I don't know for sure. We're going to find out. Yeah, we're going to find out. So this is a 24 volt supply. That's good to know. Cool. So yeah, what do I want to do? Well, first off, let's get the new power supply and let's see what we're dealing with. And we'll take some measurements and see how big it is and what kind of room we need to make. Ugh. I really like how it looks. Jupiter Company. Sounds like quality to me. Alright, so the new power supply. You can see how chunky of a monkey this is. It almost fits east-west. Almost. In fact, it would probably work. But the north-south, not so much. So, yeah. All of my cables come out of the bottom. So I'm going to want this thing to be this direction. Probably about there. So yeah, we're going to have to remove the top part of this. So, about there is where it needs to be severed and broken apart. So we'll do that and then see about what other tweaks we need to make if we do need to move these other elements over or not. Why is north-south longer than east-west? I'm not a cartographer. I don't feel I'm qualified to answer that. It is a significantly larger power supply than what was in here. I'm looking around. I think I already threw the other one away. This is twice the size. Okay. You know, I might just be able to cut this out. I'm going to try a little thing like that and see what results I get. I'm coming loose. Tighten that up. Okay. This is not a precision separating technique. Let's see if I can get something under here. Nope, that's too thick. We'll see the screwdriver. So we can pry it up. Heavy, is it linear? No, it's a switcher. God, can you imagine a linear power supply at 24,000 volts? That'd be quite the monster. Man, they have some serious fake 3M adhesive on this. Okay, there we go. There's something. Oh, there we go. Yeah. There we go. Can we rip it? Oh, beautiful. Beautiful. I'm happy with that. That looks good. So yeah, man, they got some seriously strong adhesive holding this on. So we'll toss that little piece. And we'll get the rest of this out of here. Obviously, that's going to be a problem. But yeah, we got it out. That likely will be enough room. Don't like how that's going. That's a good way to slit my wrists. You know, heat would be nice there. Heat would be nice there. Do I want to deal with that? It probably wouldn't be too difficult. I'm thinking. Am I motivated enough to try that? Yeah, what the hell. Maybe that's why Tesla went bankrupt, right? There you go. I think there might be some conspiracy behind that too, right? Wasn't there supposed to be conspiracy? Let's see. Do I want to use my hot air station? Yeah. That's actually pretty easy to get to. It won't all be on camera, but I can show some of it. Do a little dance. Melt a little plastic. I'm the laser man. From Ohio, yeah. Alright. This whole assembly method. Hello, Baloo! Oh! Happy New Year. Long time no stream. Tonight, The New Year's has arrived, and I should be back at it much more frequently. All right, we're working on a laser. The electronics for a laser. Right now, we're working on the plastics for a laser. We'll talk more about that. Doodle-doodle-doo. Is that my mouse? Is this my mouse? Which one's my mouse? That's my mouse. How many watts? 60. CO2, yes. Yeah, that's helping. That's melting a little. The high voltage power supply failed. And I bought a new one. And it's big. So I'm having to rework the electrical bay so that it fits. It's a 500 millimeter by 700 millimeter red and black. Yeah, I saw that. I'm not interested in their services. Everybody's trying to hustle. I get it. No hate. Just not something I need. All right, cool. We'll unplug that. And I believe that cleared up the adhesive that would be in our way. Whew. Yeah, nice. Anybody want some Reese's Cups? I hate Reese's Cups. Do. Hey, Jay. Appreciate the support, dude. With the new year here and a few personal objectives out of the way, I'm able to get back at the streaming on a much more regular basis. I appreciate everybody's patience as we got through things. I am now officially a private pilot. That was 18 years in the making, and I needed to focus and get it done, which meant lots of late night studying. So now that I'm done studying, I can get back to the fun stuff. So, we are reworking a 60 watt CO2 laser to install a new high voltage power supply. I like the cable management too. This is well done for a cheap import machine. So the existing high voltage power supply blew up, and the new one is way bigger than what would previously have been installed there. Oh yeah, this is gonna work nice. It's not perfect, but it is gonna be workable. So this is the high voltage supply that creates the 25,000 volts to drive the CO2 laser. And I need to make room for it to fit on this electronics board that goes back in the laser cutter itself. So you guys can probably see there's a mounting hole in the corner that needs to be accessible. So this won't just bolt in as is. I either need to remove the plastic at the bottom so I can scooch it down, or I need to move some things over so I can clear it on the right hand side. I'm thinking through that right now. What approach do I like the best? I don't need to move it down that much. Half an inch would do it. Thinking. Well, yeah. Honestly, I think I just want to move things. I don't want to give up the bottom channel because I want to be able to protect the wiring that's down there. So what we're going to do is we're going to move some things over to make room. So the other things that are on this board, this is the Ruida controller. This is the DSP that runs the laser. This is a stepper motor driver for the X-axis, a stepper motor driver for the Y-axis, and then a power supply that runs the low voltage stuff. So the steppers, the DSP, the display, you know, all the low voltage stuff. It's all 24 volts, but the laser's 25,000 volts. So yeah, so we need to shrink some stuff over here, I think. They left way more room between these that they need to have, or than they need to have. And they actually left way more room here beside the Ruida than what we need to have. So I could do with shifting everything over quite a bit. And the reason I might want to do that is because in the future, if I do finish powering the Z-axis, I need room to put another one of those in too. So this seems like a lot of wasted space to me. I got the 25 kV supply from Light Object. Lightobject.com, I believe, is their URL. And those guys are super cool. I've purchased from them before, and they've always treated me well. This is not sponsored. They didn't give me a discount. They have no idea I'm talking about them. But appreciate you, Light Object. You've treated me well, and I'll be back. Yeah, we're going to move it all. We're in this far. Move it all. So the way this works, this is just a piece of sheet metal, kind of thin. We drill holes and then tap them to hold just plain old bolts. Just plain old bolts. Oh, this has 3 on it. And that's something that's real easy for me to rework. So that's not a problem. Just a little tap and die setup. Not even a die, just a tap. You know, a drill bit and a tap. Alright, so there's those 3. And that's for the power supply. Cool. So there's the power supply. It's a, you know, cheap 24 volt switcher. A Giton D100Q 24 volt 4.5 amp and 5 volt, I think it says 2 amp. So low voltage supply. If I wanted to do an upgrade, this would be a great time to upgrade that, but that's not in the cards. Okay, so that's out of the way. Now we can pull the stepper driver out. And are those the same bolts? They are the same bolts. Good. The replacement high voltage supply was about 150, 160 bucks, which I think is a totally fair price. So this is what a stepper driver looks like. I like stepper drivers by Keling Inc. Kelinginc. That's not what these are. But Keling makes some really good, high-quality stepper drivers. I have built many machines using Keling parts, lasers, and other CNCs, mills. All right, cool. So we've cleared that out. This and this need to come out. They won't survive that, probably. They didn't before. And that glue, it just doesn't give. I wonder if heat would loosen the bond without melting the whole thing. We could try it. I mean, I can get new cable chases. Okay, we'll plug this in. We'll try it. I mean, they need to be removed either way, so whether they survive to be reinstalled or not, that's a whole nother issue. But let's see if it helps with the removal. We're going to melt things. This wouldn't be Project Blue Smoke Monster if we didn't allow for the melting of things. Come on. Melt. Detonate. These are all totally acceptable outcomes. Alright, let's see if this helps the adhesive come loose at all. It does not appear to be helping the adhesive. So then what I'm going to do is just let it die completely. This is actually cool. They're laying down. We're just going to melt them out, clear it, and then I'll order new ones. Come on, start folding over. There you go. That's awesome. This is fun. Look at them laying over. Ooh, that smell. Can't you smell that smell? The smell of melting plastic. Alright. But hey, if it comes off clean, that's all I care about. Or clean-ish. Because at this point, like we said, we're not reusing them. Okay. Working my way through the adhesive. Okay, that's not doing too bad. Heat it so that I can remove it. And we'll remove what we can. There we go. There we go. Nice. And hell, if I have to redo the whole thing, it's probably like $6 worth of plastic, so I'm not worried about it. But yeah, the heat, it wasn't helping with the adhesive, but it will destroy the thing, so it still works in the end. Later, Eric. Appreciate it. Okay. There we go. Getting there. Getting there. Alright, now, can we get this to peel? I think we just might. It's trying. That's good. That's good. Come on. Get on off of there. I'm getting a little warm for my fingers. Well, whatever freaking adhesive they use on that's pretty amazing. Given how difficult this is, I'd be half tempted to just get a piece of aluminum and cut a new electrical board. Ugh. Just because this kind of sucks. I may end up having to do that. Talk about scope creep, right? Come on, get out of there. It's just the adhesive's so strong that even like a putty knife, I don't think would loosen this up to where I could just scrape it off. It's just, look at that, I'm melting my tool. It's just so damn strong. Way to go. Import adhesive, though. Man. Alright. Tell you what. Here's what I think I'm going to do. This is a pain in the ass. I'm not motivated enough to do that. So instead, let me put the heat gun away. Instead, what I'm going to do is measure it and just see what a piece of aluminum would cost me, because that'd probably be a lot more enjoyable than continuing to peel this shit off this. All right, what do we have for size here? We need, of course it's probably metric. We'll say we'll go to the closest. 10 5/8 by 23 5/8. And I can cut this. So 10 5/8 by 23 5/8. So 11 by 24 would work. What does an 11 by 24 piece of aluminum cost? Probably not that much. Let's see. Amazon sounds like a good place to look. 11 by 24 aluminum sheet. 12 by 12 by quarter inch is $25. What do they got in 24-inch aluminum sheet? All my tape measures have both centimeters and inches. Yeah, I don't think I own one. .020, 24 by 48 is $43. Okay. Is this thing worth $43 of my time? I don't think it is. I think we're going to be buying a new sheet. And that's free delivery. So that's .02. 24 by 36. Okay, let's keep getting smaller. No, yeah, I mean, basically just 6061 T6 is probably what we're going to get. 24 by 48. Ooh, right here. 12 by 24 by .063. What do you mean no? Let's see. Convert inches to millimeter. Okay, 1.063. That is about 1 millimeter, 1.6 millimeters. That's not bad. I'd like to go a little thicker than that. That's $30. What if I wanted to go full 1/8 inch? I want to go 0.125. All right, I got a better way to do this. OnlineMetals.com. Access to OnlineMetals.com was denied. Online Metal. Are they gone? I've used them before. Oh, that worked. Okay. Select material. Here, I'm going to change this up so you guys can see. Boom. Transition. That's good. I want just the desk. Because there's nothing. Well, I guess you can see me, but we're going to move this. There we go. All right. Select material. Aluminum. Select shape. Sheet. Select alloy. 6061. All right.
Do you have fun?
Not now.
Isn't it fun?
Hold 1 second, guys. All right. We need to add a do not disturb to the door. All right, gauge. It's just 6061. Thickness. Let's go 0.125. Search now. 6061 T6. Select cut size for price. 12 by 24. 52.85. Okay, that's not bad. That's not bad at all. Add to cart. Go to cart. Estimate my shipping. I don't think it's free shipping. Yeah, it's gonna do it here. Will it not? It's gonna make me do a full thing. Well then, hang on. There, you can get ultimate zoom while I'm putting this all in. Continue. Shipping is going to be $13.54, so $71.37. $71.37. I'm gonna look around a little more before I commit to a $71 piece of metal. Boom. Let's see what else we can find. Let's go 0.125, 6061 T6. There's 12 by 18. Hey, right here. $55. That's perfect. That's perfect. Available by Sunday. I think that's the route I want to go. We're just going to make a new panel. I don't want to spend all the time on this. All right, so let's do that. Add to cart. And then let's look for 1 inch. I imagine this is 1 inch. Let's measure it. This wire management stuff. Yeah, that's 1 inch cable raceway. Yeah, there we go. $2 a foot. That's not bad. Yeah, basically this stuff right here. Does it have... Yeah. What length is it? 15 inches. The longest I'm going to need is 24 inches. 1 inch wire duct. Come on. 1 inch wire duct. Inch and a half by inch by 6.5 feet for $17. Let me see, is this 1 by 1? It's 1 by 7/8. I wonder if there's another place to get that. 1 inch cable duct. Automation Direct. Yep, they definitely have it. Graybar. Okay, Graybar would have it. Granger would have it. McMaster Carr. Masumi. Lots of places to get it, it looks like. What about AliExpress? I can never read their website because it like comes up in weird languages. Like it thinks it's in Portuguese. And I don't know how to tell it not to be in Portuguese. Who speaks Portuguese? I mean, I can have Google do its translate, which is not helpful. But it shouldn't be in Portuguese. Let's look for 1 inch cable duct. Cable raceway. Cable tray. Cable management frame. No, I know it's out there. I just don't know what they're calling it. 1 inch nominal width. Inch and 5/8 high. We don't need it that high. Width and 1/4 by inch and 5/8. Okay. So there's some stuff at Granger and such. Well, what I'm going to do then, I'm going to shop around, see what I can find. But I think for the effort involved, it's not worth wasting my time trying to clean this up. But I may change my mind. I may take some more aggressive tools to it. Maybe I take a grinder to it and just smooth the thing off, and then I hit it again with a sander, and then repaint it. I mean, I could do that, but I'm not ready to commit to that level of effort yet. Some things it's just easier to replace than to rework. But this was really good progress. I'm happy with what we've done so far. So let me figure out what I'm going to do with this electrical panel, and then we'll get back to remounting the electronics and wiring. This has been pretty productive. I'll keep you guys posted as progress is made. I want to kind of get this done sooner than later because I have some projects I'd like to cut on this thing. So with that said, I appreciate you tuning in tonight. We are going to make a huge attempt to try to make a lot more content this year. Keep everybody engaged. Get some projects done. I actually just posted an older live stream up on the YouTube channel for Project Blue Smoke Monster when we were working on the design and ordering of a prototype power supply for the microcontroller trainer. Now, we're probably going to throw that design away because the parts that I really wanted to use that I couldn't get have become available again. So I think it's time to do it the way we really want it. And as part of doing that, we're going to just build it on the main board. I am done with playing around with modular ideas. That was a COVID thing. That was a supply chain thing. But I don't want to do that. That's not how I want the product to work. So we're going to do it different. With that, 2023's got a lot in store for us. And I look forward to sharing it with you guys. Thanks for tuning in. If this is your first time, I'm going to show you a little stream here of what else to expect next time on Project Blue Smoke Monster. See you guys later. Holy crap. Did it just desolder itself? I think it's desoldering itself. One end of the coil goes to the antenna connector jumps to the diode. The diode is our audio path, and this comes out to the headphone. One of these days I'm going to fix the squeaky chair on the screen. So if you want one of this rev, it's available to ship now. Oh yeah, can't do that here. Can't do that here. Gotta do that in the other part. Boy, I've got that heatsink hot. Like hot. Like feeling hot. I mean, this is not going to be a showstopper that stops me from developing this. If I got to deal with line of garbage for this badass capability, I'll deal with line of garbage. And the microcontroller trainer is a learning environment, experimentation environment, development environment. You come up with what you want to call it.